What I'm going to do in this video is show you how to configure static routing. So as the name suggests, static routing is not based on any dynamic routing protocols or exchange of routing between different neighbors. It's based on the manual configuration of a route on a router or layer 3 switch. And that's the first difference between that and dynamic routing protocols such as OSPF and ERGRP. The other difference is static routes are not advertised to neighbors. If I configure a static route on R1, for example, that's not going to be advertised to any neighbors. And anytime you have routing set up, whether it's dynamic or static routing, you have to have a path in both directions, both forwarding and reverse, to have network connectivity between a host and a server. Now with dynamic routing protocols, that's done automatically. The neighbors exchange routes. With static routes, you actually have to configure another static route on another router to make sure packets are forwarded in the reverse direction. What I've got here is a layer 3 topology with 3 routers, and I've got a host on 172.16.1 subnet and connected to switch 1. I also have this server here, and this is on 172.16.2 subnet. The address is 172.16.2.1. There's currently no routing configured, so what I'm going to do is I want to configure a route on R1 for host 1 to forward packets to provide connectivity to server 1. I'm also going to configure a static route on R2, and that's for the reverse direction for packets from server 1 back to host 1. If you're going to configure a static route, you want to do it based on the most direct route. So I wouldn't configure something on R1 for R3 and then R2. That's not typically what you would do. Typically, you want to configure a static route for the nearest next hop, and that would be R2. And here it's 192.168.1.2. That's assigned to FA10. So that's going to be the next hop from R1 to R2. So you note server 1 has a /24 mask, so that's part of the route. So I'll select R1. So you read this IP route from left to right. To get to destination 172.16.2 with a /24 subnet mask, that's the route to the server, since it's on that network address. Take next hop 192.168.1.2. So there's 192.168.1.2, FA10 and R2. So a route has a destination prefix and a next hop address. That's all there is to that. So now I want to go to R2 and configure a static route in the reverse direction. That'll be to R1. This will be 172.16.1.0 because that's the network address of host 1. And they're assigned a /24 subnet mask. And the next hop would be R1. That's 192.168.1.1. There it is there. 192.168.1.1. So that looks pretty good. Just save that on R2 and do a save on R1. What I'll do is I'll just do a show run, make sure the static route is there. There it is there. Say I wanted to change this route if there was an error. You always have to remove the current static route before you add a new one, or it'll just leave it there. So if I do show IP route, got connected routes, and there's the static route there. Got an administrative distance of 1. And it's got the correct next hop, 192.168.1.2. We'll go to R2 and do the same thing. There it is there. That looks fine. That's the route back to host 1. There's the static route there. The 10, that's the 1 is the administrative distance, and 0 is just the metric. Static routes have a 0 metric. And there's the next hop back to R1, 192.168.1.1. That's that interface FA10. So we'll go to host 1, see if I can ping server 1, 172.16.2.1. And I got a couple replies. So I'll try it again. This time I got all 4 replies. Now that ARP's been resolved. And I can do a trace route as well. What have I got here? 3 hops. So 172.16.1.3, that's the default gateway. That would be FA20 there on R1. Next hop is 192.168.1.2. It's FA10 on R2. And then the destination, 172.16.2.1. And that's server 1. That static route is working fine. And that concludes the video.